me start to record. So I will repeat. So for this task, for task 11, you have to make a separate project in your workspace, which is only for that one single project. And then you have to initiate it, and then you have to use commits and merge requests for that project. So you cannot reuse the structure where you have task 1, task 2, task 3, and so on. And then you clone it from the course. You have to copy it and create a new project afresh. Okay, is it like clear? Yeah, great. All right, so let's start. It is, I hope, pretty straightforward. So we will see how it goes and what you already know and what you will learn. So what we'll cover today is a little bit about the project layout, how you should lay out your Golang projects. You probably had that discussion with Christopher already. How to use make and Makefile for your tooling, and what sort of tooling should you use, and specifically, why should you use Golang CI-lint? If you're not using it yet, then definitely you have to use it. Then we will talk a little bit about semantic commits, how we making commits and how we naming them, about branches, how we manage branches and how we name them and why we use merge requests, and then how we automate everything with CI pipeline. So this is the reason why you have to do it as a separate project, because you want to have a CI pipeline for that project, which will check everything that you need to check. So every time you push to the GitLab, it will run your pipeline, it will check that your code passes all the tests, and then you will be happy that like nothing happened. It is a little bit like toy for us because it's an individual project, so it'll be just one developer, right? And that's fine. We're just toying with it. But for assignment 2 in cloud, you have to do group project. And then for a group project, it makes a lot of sense to have a CI pipeline, because if someone commits something, then we can be sure that it didn't violate any tests or any regressions, and that it follows the coding conventions and so on, right? So for a team project, it's a must. For individual, yeah, I mean, if it's just one person and you kind of reviewing your code, then making merge requests is a little bit of an overkill, because you can review your code without the merge requests just for pushing into main, right? But we're just doing it as a kind of a practice. Sometimes you will be using coding agents. So it's not only you, it's you and the coding agent. And then you want to review what the coding agent did. So you want the coding agent to make a merge request, and then you can review what changes it did. So you can sort of say, yeah, I accept all those changes, or it's like, no, what is this? Like, this needs to be fixed, right? So for coding agents, you do have to have merge requests and code review, even if it's just one developer, right? So it's sort of like, it's a good practice. Personally, I'm lazy and I often don't do merge requests. I'm just doing alone work, but we doing some work with Christopher, and then we do merge requests. Like, we actually create a branch, do all the changes, and then I or Christopher like make a merge request and say, okay, can you review it? Can you see, like, sanity check if everything is okay? And it also communicates what has been done. So we both know like what has been done. So even for a team of 2 people, it's super useful. So you should do this. You should do this. Okay, then we will talk a little bit about idiomatic Go. There is not a lot to talk about, but a little bit. Go is very simple language. That it's very easy to use it properly. If you're using linter, it's very hard to not use it properly, because the linter picks everything. Like, it's such a simple language that you don't need a lot of sophistication. The Golang CI linter is superb. Like, it will pick all your mistakes and all your code smell and everything. Like, you don't almost need a reviewer, but we need reviewers for more architectural kind of constructs. And then we will do this practical thing, the practical exercise. All right, so what do you like about Go? So you've worked with Go for a bit. What do you like about it? It is simple, easy to understand, easy to learn, works well in VS Code, yes. Yeah, it's similar to C, it's easy, It fits your natural way of thinking, coming from imperative programming. It has familiar syntax. Yep, I also like Go for all those reasons. I also like Golang for speed, like building things super fast. Like building things in Haskell, okay, sometimes takes a while, especially if you need to load all the test frameworks and stuff, dependencies, takes a while. Building things in Rust, same story, takes forever. Building things in Golang, even for large projects, almost like super fast. So I also like speed. The other thing I like about Go is super nice integration with Docker. So it's so easy to make a Docker container which kind of builds your Golang executable and does something like a service. So using Golang with Docker and with services, super nice. The other thing I like about Golang is all the built-in system libraries. So when you need to build like a REST service, you don't need any dependencies. It's all in the language, which means your code base is super maintainable because you don't need any updates for the dependencies, right? Every time you are relying on somebody's software, on third-party software, they find bugs, they find updates, and you have to keep your software updated. But with Golang, like if you don't depend on anything outside of the language, it's super nice like to maintain it because you just say, okay, now I'm using Golang 126 and everything works. I don't need to bother with any dependency hell and so on. So there is a lot to like about Go and I use it a lot, and it is, yeah, very nice language. It is super simple and it is not Haskell. So for example, if you're doing advent of code puzzle solving, I would never use Golang. I mean, it's such verbose and such a boring language to work with that I would pick Rust or Haskell to do some fun kind of puzzle solving, like an advent of code. I would never do them in Golang, right? It's just not fun. But to get work done, it's great. All right, so project layout. Of course, there are multiple ways of doing project layouts in Golang, but the one which sort of works most of the time is that you are following some conventions. And one convention is that if you have an executable, if you have to have a main module, you put it inside a CMD, right? It sort of communicates that, okay, if someone gets your code base and it's looking, okay, where is main? Where is main? It's like, yeah, it's in the CMD. It's so easy to find, right? So if you have multiple files, you can sort of point to CMD, and if you have only one executable, you can put main.go directly there. You can say main.go here, and it will be named as the package name. If you have multiple, you say the application name / main.go, another application name /.go, and so on, right? So if you have multiple applications like client and server, then you say command server, command client, and then you have main go in each folder. And it's like easy to follow. And then in the root package, you keep your files for your main package. So if your main package is tic-tac-toe, you say, okay, my module is like my main module is called tic-tac-toe, and then inside here I will have a package which is called tic-tac-toe, and then all like I will split the logic into individual files, such that if the person wants to say, okay, where is the player logic? There will be player.go. Where is the game logic? Game.go, and so on, right? So by file name, it's kind of easy to organize. Of course, you have go.mode, and then you have a Makefile. Why do you want to Makefile? Well, we are lazy. We don't want to keep typing go test, go build, go vet, and so on. We want to have everything kind of organized in such a way that we can automate things. So if you have Makefile, you can streamline some of the commands that you have to use all the time. And also, after like 2 months, you can say make help and print to yourself what the commands you can use, like make build, make vet, make CI, and so on, right? So this makes our life much easier. And then again, you can put the executables in the main folder, but for ease of git ignore, it's nice to put them in bin, right? So have a folder called bin, and every time you're building stuff, you will put them in there, and then you git ignore it such that you don't accidentally commit it to the repository, right? Does that make sense? Very simple, very logical, easy to follow, nice practice. Can you do other things? Of course, you can do other things, right? So if you're working in a team and you have more complicated project, you can agree to do something else. But at default, this works pretty well. All right, so why command for executables? Because it kind of contains, like you want the main.go to be simple, and you want it to be isolated from your library code, and you want it to live in its own package, which is called main, and you want it to be like one line of code or two lines of code, like really simple. Just assemble things from your library and call, execute, or run. Like you don't want to be doing a lot of logic there. Because we normally don't test that file, right? It is sort of a file that does not have its own tests. It is used for end-to-end testing, but not for unit testing. Therefore, the logic there should be like 3 lines of code or something. Like it's so obvious and so impossible to have errors that it's like very simple. And it's doing just one job. It wires all the dependencies from your library and calls this one entry method into your business logic, right? All your business logic lives outside of main, lives in the package, the root package. And that keeps the main very thin and business logic testable, right? So you kind of isolate those two things separately on purpose, to have the executable part really thin. Okay, and then we can have flat package structure. So as I was explaining with tic-tac-toe, you can have like domain logic in files and like game.go, render.go, player.go, and then errors.go. And then if a new person comes in, it's kind of logically organized. It's easy to jump in and understand that I have game logic in game, that I have some rendering logic here, and all the player definitions there, right? It's like logically organized, and I don't have a complexity of packages and so on. It's just like one package, tic-tac-toe with this. If your project grows such that this root package becomes actually like 20 files, then you have to think, okay, then it's like finding stuff is a little bit hard now. Maybe we need a hierarchy. Maybe we need a package, say networking, and then I have 5 files under the networking package, right? So maybe networking needs to be separated from GUI or something else, and then I have packages, right? And then I have tic-tac-toe networking, tic-tac-toe GUI, and then I have 5 files here, 5 files here. Then it makes sense to introduce abstraction layer, but avoid premature abstractions, right? Don't over-engineer it. Don't create all those like packages up front saying, oh yeah, I will need networking, I will need this. No. Start with like networking here. If this file grows too big, or if you have too many files, then refactor it. But don't like introduce premature abstractions. And then if your one package grows too big, then introduce complexity later, right? You will have to do a little bit of copy and paste once you introduce the complexity, right? But it's much better than introducing those dependencies between packages. That complexity, if you don't need it, is like unnecessary. Does that make sense? Great. All right, so then, oh yeah, we have a quiz. Nice. So let's see. Let's see how it goes. I think the quiz is about what you just learned. So let's see. Very nice. Is that true? Yes, it is technically true. Like you can basically have the main package like anywhere, but it's a very bad practice. when you started, you probably did this, okay? And this is like the basic thing, like you have your logic and then you have main.go, and then the main.go like does things and everything is in a main package, right? It has several problems. So one problem is that, I mean, one good thing is that person coming in says main.go, okay, like main must be there, right? So that's okay. But you can only have one main, right? You cannot have multiple apps. The second problem is if you're making the tests, because you cannot really test main.go, your test coverage for that package will be lowered by what you're not testing in the main method, right? So you cannot have 100% basically. And if you isolate it like in the command and test now this, you actually can reach 100% because you're actually testing everything. So there are some like tiny things which like allow us to like to do better when we do this pattern. All right. Whoa, another quiz. Okay. Let's see. Okay, what should we have inside the main.go and our my app? Yeah, of course. So should you do command line parameter parsing inside main? No, you should not. If it's simple, you should have it somewhere in the business logic. If it's more complex, you should have a special CLI.go file, where you pass the command line parameters, it does everything, and so on. We often want to combine command line parameters with the operating system environmental variables and a config file, right? So often your application, if your application is actually a little bit like a normal, and for cloud, you may need something like this. You want a config file, and then you want the config file to either have defaults or use environmental variables, right? If there are no defaults. And then you want the user to be able to overwrite it by command line. So you want a kind of a hierarchy that command line overrides the config file and config file overrides the environmental variables, right? And then the user can sort of decide what to do. And if they want to override something, they can use command line to override something. So this complicates stuff, and maybe CLI.go is a good place to do all this logic, right? All right, Makefile. So we are done with part one. We're doing well, I think. And part two, Makefile and tooling. So we want to have a setup such that you and your friend have the same kind of tooling, and also you and the CI pipeline have the same tooling, such that you doing the same thing and CI pipeline is doing the same thing and your friend is doing the same thing. If you don't have Makefile, it's very hard to see what everybody is doing, right? Which flags everybody is using. If you use a Makefile, then you unified it. It's sort of consistent. Super easy, very trivial to set up. When I was a student, I had my mini project with all this template, and I was just copying and pasting stuff and then had the wiring done initially, like when I start new project. You can do the same. So you can reuse the tic-tac-toe examples and sort of wire yourself up. So it's a single source of truth for every task. Everybody is running the same thing, and Docker also helps with this problem. So you can even Dockerize it if you need to. For cloud, it might make sense if you need more than one service. And then you have some typical targets, right? So make build builds the executables, builds the artifacts. Make test, tests everything. Make vet, runs the vetting, go vet, and runs the linter to check if everything is actually correct. Make tidy runs the mod tidy, and make CI makes all your stages from the CI locally such that before you push, you can check if your CI pipeline will pass or not. So you should not like push something and then it fails the linter or it fails the test. You should test it locally and then push when everything works fine. and then cleans your caches and cleans your executables, and you have kind of like a clean build, right? So can you have different strategy? Yes, you can. This is just an example, and this is sort of like a default. Some people split vetting and linting into two separate steps. I don't see much of a difference, especially with Golang CI-lint. It has Go critic. It has a lot of like vetting built in into the linter. So then the boundary between vetting and linting is blurred. It's sort of like almost the same. So I kind of combine it. And it also makes life a bit simpler. And it's a little bit up to you. Again, it's just like a default. You can, depart from it. You can do a little bit your own thing, but you have to agree with your team, and it has to be like easily communicatable with other developers. So yes, I already talked about it. So build, compiles, and places the executables in the bin. Run all the tests. So like go test and test everything. You can specify which packages to test, or you can use this placeholder for everything. Vet runs go vet and Golang CI. Go vet is okay. It's quite good. But Golang CI-lint with the flags, which I show you in a moment, it's better one. It actually is a superset of this one. So if this one detects something, this one will detect also. If this one detects something, sometimes this one will miss it. It's good to run both, but this one is like stronger. This one is just for tidying your dependencies. And then for CI, you want vet, test, and build. So you want to run it in that order, right? All right. Versions. It's so nice if you have a versioning of your executable or of your project kind of set up in such a way that you don't have to think about it. And it's super nice if it is wired with your commits, with your Git usage. So it is not a must, like you don't have to do it, but if you are doing it, you're kind of demonstrating that you're really thinking about the user and other developers, because it's super easy to see if something does not work, in which version it does not work, right? So I can show you. Let me show you. Wait a minute. Where is? Okay, so I cannot drag things here because it's a full screen. Right, so let's make. So I have some projects. Projects uni. Yeah, I have, for example, this one. And then I am following what I preach. So I have an executable inside bin. It is a Golang project. I can ask the version, and I get this, like I have it wired such that I know my version has been built from this tag. It's built from this tag, and it's the 6th commit after I've tagged it in the Git. And then this is just the commit hash, the beginning of the commit hash, right? So if somebody is doing it and they have the same tag, but they have a different commit count, then we can easily see, okay, you are missing something, right? So then what I can do is I can say, I would say git tag, let me, okay, I can do git tag, annotated tag version 0.0.2, and then I can say it's also dev, and I can say demo for the class. I will actually mess up my versioning because I am still with version 0.0.1, but it's okay. And then I will push it. And then if I make it now, if I make build, it will build. And now if I run my executable and check what version I am now at, it will say, yep, you are at the version 0.2, right? So it's very automatic. I don't have to go and change my version in the source code. It's super nice. And it's very easy to communicate with the rest of the team of what you're actually running, right? Because you have this sort of pattern of tag plus how many commits after the tag. I currently have no commits, which doesn't do anything. And then I don't have the commit hash because I am right at the tag, right? So if the person needs to get exactly to that point, they just need to git checkout with this tag, right? So then this additional information is not needed. It's only needed if I have some commits, right? So again, if I do, I don't want to demo it. It's really a tool that we are using. So, but you get the idea. If I did a commit, I would get this sort of a commit one with the hash, right? And also, if you don't push it yet, if you didn't committed your commit, then you will get this flag that you're actually running a dirty version. So you did some changes, but you didn't push them yet to the repo. And then you have this kind of a flag that you're actually running your local copy, right? So it's super nice to see like why some things don't work because you see all these versions. All right, so again, I encourage you to use that model, but it's like strictly not necessary every time, but it's a good practice. All right. So again, a quiz if you're paying attention. Yeah, nice. So in the early days, so you could think, yeah, build like does everything. Like not really. Like build should only build the artifacts. So it is possible that your make build will do everything, but then it's a little bit confusing, right? Because the expectation is that build should just build. It should not test or VI or vet, everything. Make all used to be the default target, but then it is a little bit confusing because does make all makes all the artifacts that I need to build, or does it run everything, including the vetting and testing? Like it's a little bit unclear, right? So make CI is a little bit clearer because it means, okay, make CI runs all the CI phases, and then in the CI you have to vet, you have to test, and you have to build their artifacts, right? So it is sort of, again, it's a convention. You can put it here or you can put it there, but then it's a bit confusing, right? So it's better to have it kind of isolated. And the other ones, like don't use this one because this one is kind of confusing. And make build only builds the artifacts, make test only tests, make vet only vets and runs the linter, and make CI kind of runs everything. All right. Which one is this? Okay. So I spent some time talking about that. Exactly. There is one extra beautiful thing about it that is there was time when I did not use it. So imagine that you're not using it. So then you have a variable called version in your code, and then that variable is a string, and you say 0.00 def, okay? And now you did all the work, your repo is synced, and now you want to release 0.1. You are ready to release 0.1, right? So then what do? You change that variable name, but because you changed it, your source code changed. So now you have to commit that change to the version, right? So then you're pushing the version. So then you have the situation where you're ready to release, you're tagging in your source code that this is the 0.1 tag, but you forgot to change that version number. So now you have one commit less because you have to push that commit. So you have a mismatch. And it's so annoying. Like I never got it right. Like I always was like, oh shit, now I have to tag the other commit because That's the real release, not this one, and it's like a hell. Like this one doesn't touch your source code, right? The source code is what it is. Like you're not changing the version in your source code, so you don't touch it. You're just tagging the commit, right? So it kind of decouples the versioning of your software with your actual software. Okay, so then the big one, the Golang CI-linter. You have to use it, and you have to run it for your cloud course, and you have to run it every time you're using Golang. If you, where do I? Yes, let me show you. So I have to make the window. So if I go Golang CI-lint, if I like run it, I have to make the window smaller, linters, because it's like really a lot of them. You see, there are so many different checks you can do on your source code, right? And then you can run them all and be a little bit overwhelmed with what it complains and what it checks. And some of the checks are a little bit pedantic. Like not all the checks make sense. So we have to find a balance, right? It's sort of like a curve. If you don't check anything, then your code is really bad. If you check everything, you can't get it. Like you cannot, because you have conflicting objectives, right? So it's too much. So the best code is kind of somewhere in the middle. So you cannot use all of them, but you have to cherry pick which ones make your code the best it can be, right? And it comes from a little bit from experience, and it comes a little bit from like playing with it, right? So kind of through the experimentation and through some of the experience, I recommend those linters. It's a subset. You can pick the subset for your project, and you can be annoyed with some things in your code that those linters don't check, so you can introduce it later. But these ones are kind of a good default. It's kind of a good starting point, okay? What is Golang CI-linter? It's a fast parallel linter for Go. It runs super fast. It's very configurable. You can configure it via flags or via the configuration file in your project. And then it should be enforced in your CI, right? If it fails, you stop. You say the developer, look, you screw up. You have to fix things, right? Before I even build or test anything, right? And you can run it in the command line. So if you run it in the command line, it's sort of like this. So you say run, and you specify which linters to run. So what are the linters? So Go Critic is like your Golang assistant. It's like AI for Golang. So it checks your code. It makes a semantic and syntactic analysis of your code and nitpicks what you are doing wrong, right? So this is a great tool, and it teaches you Golang because it teaches you what not to do, right? So I highly recommend this one. This one is sometimes annoying. So what is cyclomatic complexity? If you have source code and you say for loop, and then you're doing something, you have a block of logic, which is doing something. But inside this block of logic, if you say if, then you have another one. And now you have nesting of two. If inside this if, you have another if or another for, that's nesting of three, and so on. So if you keep nesting that structure, reading the source code becomes really kind of troublesome and complicated, right? So cyclomatic complexity checks how complex is your source code because of those nestings, right? Ideally, you should not have nesting like more than 5 maybe or 6, but often you kind of have to, like you have some case and then you are doing some logic, maybe you have some loop. So like doing up to 5, 6 is normal. And this one checks if you exceeded 15. Like if you have nesting 15, you're really doing something wrong in your code, right? So it will kind of pick that. GoSeg is super nice. It kind of checks all your security vulnerabilities, all your user input validations and things like that. So it's something we normally don't like consciously think about, but it kind of picks some of the security concerns. This one is easy, like don't use magic numbers in your source code, and this one enforces it, like you will not use magic numbers. This one is the same, but for string constants, right? If you hard coded some constants in your code, it will say, no, no, don't hard code stuff, use constants, right? And then this one is also annoying because it says you should not have errors ad hoc. Every time you're throwing an error, you should define it somewhere in the error.go file that you have all those errors such that new developers can come and see what errors are possible. And then when you're throwing an error, you should not say new because then it's ad hoc. You should reuse the sentinel errors, right? So it has two functions. It says you should define or declare all your errors, what can go wrong somewhere such that it's communicated, and then you should reuse it. You should not create like ad hoc new errors, right? We often do this. We say, oh yeah, I am doing if error, then I'm throwing a new error. And often we reuse the same error, but we make like small typo. Like sometimes we say missing string or say missing strings, and then there are two different errors, right? So then if you have them in one place and you're reusing them, then it's like having a constant, right? You always throw the same error and you have no typo problem, right? So it's a good practice. So those 6 are kind of like my favorites, default. You can add extra ones. You can read what extra ones you can throw in and add them. But these ones are already making your code kind of super nice. And then, okay, so what is magic numbers? Like if you say, if length of board is 3, where is this 3 comes from, right? You should have it a constant. You should say that the board size is 3, and then you communicated what the 3 comes from, right? So just use constants. And then if you say if length is board size, then it kind of obvious what you're checking. Like if you have this in the code, you know what it is, but in 3 months you will not know. Like why it was 3, right? Error discipline, as I said, don't throw new errors. Don't say new invalid input, because then it's like you can make a typo or it is like not easy to find what all possible errors are. You should declare them. Declare all your errors and then use them. And then you can also wrap them, right? So if you have a new error which adds some information to the existing error, you can wrap the errors like this. And that's also fine, right? So you should declare all your errors, and the convention usually is you have some variables called ERR and whatever, right? Good practice. Cyclomatic complexity, I already explained. You will see that cyclomatic complexity will point out every single time if you are doing something like messy in your code. All right, so a quick check if you were paying attention. So which linter will pick that one? Yeah, Go has this sort of mnemonic package naming convention and so on. And it basically means magic numbers, right? I don't know why it says D here, but it's like magic numbers, which is a little bit confusing because I always confuse these two, like these two. So in some path linters, like for other languages, like I think in Java, you have linters for all languages, but in like the literal constants and the magic numbers were combined into a single kind of thing, right? That you should use constants basically, right? And it's the same, like the magic number detector is basically about setting constants for numbers, right? So those two are a little bit confusing and the names have nothing to do with one another, right? But after you've used them for a bit, you will kind of remember. Anyway, let's move on. Wow, another quiz. I don't know why this linter is called 113. Maybe we should check it. Yes, perfect. So you're getting the picture. All right, semantic commits. Who is using semantic commits? Who knows what they are? Nobody's using them? Great. So that's good that we talk about it. So if you go to this website, yes, open the link, you will have a nice description of the conventional semantic commits, and they will reiterate some of the standards, and I will kind of repeat as well. So it's basically type what you're doing, in what scope, and then followed by short description after a semicolon, after a colon. So what you're doing, where, colon, and then short description, right? So if you're working on a feature for a game, you say fit game. If you're fixing something, you say I'm fixing, and where is the fix? If you're refactoring, you say you're refactoring where. And then for tests, you use test. And for maintenance and some CI, for CI, you use CI, but for some refactoring or some dependencies, you use chore. So then, for example, you say chore dependencies, upgrading golangci to 162, and CI add Golang, blah, 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 right? So you can put a small text after. You should put a small text after. You should put the context, and you should put what is that commit about. It standardizes communication. It makes it easy for other developers to quickly understand what commits are for and what you were doing. And it also allows tooling, because you can sort of see how many fixes we were doing in the code base, how many refactoring you were doing, how many features, how much work went into features, and so on. So if you follow those conventions, you will have additional information and additional structure in your code to do some analytics on your team or on your code development. So those are the commit types: fit for feature, fix, refactor, test, docs, chore, CI, and performance improvements. Also, if you're doing this, it means when you modify multiple files and you are preparing commit, and you say like new version, right? And you commit everything. That violates this. Like you have to think, okay, which files, what did I do? Did I did test? Then you have to isolate them and do a separate commit for tests. If I did refactoring, I kind of have to pick the files which I did refactoring in. So you are organizing your commits in a more structured way. You're less sloppy, and that communicates the work, right? All those giant commits where you did a lot of things and committed everything, those are really bad. In the short term, and if you just one developer, of course, it does not matter so much. But if you are within the team, you cannot allow this. You cannot allow somebody to work on 20 files and making a commit and saying fixed it, right? Like what has been done? Like what has been changed? Why? Because software lives. So software is not like something that you do and forget. Something is deployed, bugs occur later, exploits occur later, and then you have to track. You have to see like what went wrong somewhere in the past. And then all of this helps, right? So if there is an like introduction of an exploit in a multi-team developer setup, you have to know like how come that exploit now is in the code base? What happened, right? So following this helps you to debug what happened with the process. So it is all about the process, right? And the quality of the process. Okay, another quiz. It gets a little bit of used to, like it gets a little bit of used to remember those commit types and sort of start thinking, yeah? We can have a break, yeah. So let's do the quiz and then we'll have a break. So it kind of takes used to, but once you've done it for a bit, like once you've done it for one project, it becomes second nature, right? It is like actually much nicer to do this than to coming up with like a commit message to a mess that you've done. Is like, okay, what did I change, right? Should I describe it? All right, so let's do a quiz and then we'll have a break. 2 questions. Two easy questions. Oh, come on. So this is like a good, yeah, destructor, because it kind of has a good message, but the type is wrong, right? You should use test. It's not a feature. If you're adding tests, you're not adding a feature, right? All right, so one more. So you change the function name, but you didn't change the behavior. Yes, it's refactoring. So refactoring means you've changed the code, but it's doing exactly the same as before. It's just organized differently, right? All right, sweet. So let's have a break. I will, how much time, how much time do you need? 5 minutes? 10 minutes? 10? All right, let's have 10 minutes then. Perfect. And I will stop recording. All right. So let's talk about branching and merge requests. Where do I have my... Okay, so why do we use branching? We use branching for bigger control, same as with the semantic commits. And we usually want the main branch to be protected. So it is typical for, and it's a default setup in GitLab, that the main branch is protected, which means developers should not directly commit to the main branch. You as the owner, you can, but everybody else you've added, like the developers, they normally cannot. So you probably didn't observe it yet if you didn't work on a team project, but if you did work on a team project, then you would see that, yes, the main branch is protected, and you have to go through like a merge request to actually get some of the work merged with the main branch. And it is a common practice. So it is a common practice. Again, I am using it with Christopher, and like sometimes one of us pushes something directly to main, and then it's like a faux pas, like we have to apologize, like, yeah, it should not happen, right? Why? Because that sneaks in without the review. It's sort of the code sneaks in into the main branch without the review. And the main branch is usually the one which is stable, compilable, testable, and you can kind of test it, run it. So it's usually the one which sort of runs. Sometimes you want to have a production branch where you keep something that you actually shipped, but often people ship from the main branch. All right, so then its main is always in the deployable state. And then you can have conventions of how you're naming your branches. Because you're using GitLab, what you can also do is you can kind of say bug and then the slash or bug dash, and then you can use the number from GitLab of which bug you're fixing, right? So in the issue tracker, you have bug numbers. So like bug number 97. So instead of like saying here the text, you can say the number. it is a little bit less communicative because the person who is reviewing the tags or the branches has to kind of also use the issue tracker to know what it is. So usually it's kind of good to combine human readable kind of mnemonic with something to link with the issue tracker. So another common so the issue tracker numbers are kind of good to use inside the names of your branches if you can link them together. And then you're doing merging through the merge requests. And try never to push into the main branch. Sometimes we call this one bug instead of fix. Obviously, when you're working on a bug, you're trying to fix it. But sometimes you call it fix. So again, it's a little bit up for the conventions. And whether you will use numbers or whether you will use the kind of short descriptive names, it's a bit up to you. I kind of like the numbers because they are very unambiguous. Like I know this work is for that issue, and a lot of comments and a lot of reading or discussions happen in the issue tracker. But it depends on you. It depends on your team, what you want to do. And then the merge requests. They should be quite small. You don't want to make a merge request which touches like 50 files and fixes like 5 bugs, because then it's a lot of work for the reviewer to do it, right? Like the process of reviewing a merge request should be relatively quick. Sometimes it's unavoidable, like you're doing some refactoring and you have to touch 20 files. That's okay, but try to avoid it. So try to keep the scope small. Try to always link it to an issue or a task from the issue tracker. You have to review it yourself. Like you have to check it if you're not doing something stupid yourself. And you also have to check that your CI works fine. Normally, if you did a push, a merge request, and the pipeline does not pass, the reviewer not even review it, right? Because you cannot merge normally a merge request with failing pipeline. So I have a student and we work on a project as well together, and he often makes a merge request which fails the pipeline, and he has another merge request which fixes why the previous one was failing. And the reason is that when you are ready with one merge request and you are ready with the branch, what you do is you say git checkout B and you create a new branch from this branch. So you have main, you kind of are working on the feature, you are ready with the feature, you're making merge request, and when you are waiting for me, or he is waiting for me to review it, he starts a new branch from here and he starts working, right? And then if this one has some problems, he fixed it here already, so there is no point now fixing it here because that would affect this. I mean, you could, but then you have to like propagate the changes to the other branch, right? So sometimes it's just easier to say, okay, Mariusz, we can accept this one because in 20 minutes we will be accepting this one and it fixes the pipeline. So the one which is like the last one to be merged has to be green, has to be clean. Clear description, what has been changed. And then you normally don't have debugging printouts or doing any debugging anymore. So if you're making merge requests, that means this code is production ready, should be merged to main, and I'm not doing any debugging or things anymore, right? So you should kind of strip all your debugging or checks from the merge request. Okay, so when you are the reviewer, and you will be the reviewer of some of the repos in the cloud course and in this course, like how you go about the review, okay? So the first thing that you do is you check the README file and you check what's supposed to be done, right? So you have to like establish what's supposed to be done. In cloud course, you know, because the assignment tells everybody what needs to be done. So you sort of know it, but if you're reviewing the code, it should be also in the README file, right? So you check, is there a README file describing what should be done, okay? So, and is what should be done correctly done. Then you're checking the tests. How much test coverage is there? Is the critical kind of things tested? This tells you about correctness as well. So those two are linked, because if there are no tests, it's a little bit harder for you to establish all the correctness of all the paths. But if there are tests and the tests are like 80% coverage, it's like, well, yeah, it's probably sweet, right? So you check the test coverage and you check the README file. Then you kind of checking the code. If it's like a big merge request and like many files, you kind of read the code. Like you scan it, you sort of read it, you get a feel. If you sort of follow it, you don't have to understand every single detail, but you have to sort of understand the general flow and general architecture. Is it readable? Is it like something is really complicated, right? So sometimes you can override the linter checks by saying, please don't check linter for that method or that function. And for cyclomatic complexity, you can say, please don't check my complexity for this function. And this function is like super complicated and a lot of nested loops and a lot of nested ifs. And it's like, I don't know what's going on. Then you should complain. You should say, yeah, why this method is so complicated? And then you check for code smell, how errors are handled, if the globals are used or not, and then you check the GoSec. So like the readability, you can run the linter for this and for that and get the feel as well. And then you should sort of enforce some of the linter checks if the person is not checking it, right? So if the person does not do any linting, you can run the linter and tell them, okay, you have to fix all those linter problems. That's the cheap way to kind of complain about stuff, right? And then GoSeg will pick up some security things. Sometimes it's a little bit surprising, like GoSeg complains about like, oh yeah, you're using here an unsecure random number generator, right? And it's like, yeah, but it's in tests. I don't care about security for tests, right? So then you can override the linter. You can say, yeah, please don't complain about my random number generator for tests because like it makes sense not to be super secure. Okay, so I think this is quite straightforward. Any questions here? It shouldn't take you hours, right? Like doing a code review on somebody's work should not take you very long time. You have a little checkboxes, you're sort of going through your checklist, and then you get the feedback. If like there is a code smell, you complain. If there are some non-idiomatic Go patterns, you complain. And it's not your responsibility to fix anything. It's your responsibility to find it and like say about it, and that's it, right? You're not suggesting how to fix it. You're not suggesting where to fix it. You're not actually fixing it. You're only detecting stuff, right? You should not be nitpicking. So when you're doing code review, you should be as gentle and as nice as you would like others to be to you, right? So if there are some minor things that could be improved, maybe you can just like, okay, it's okay, right? Don't be very like nitpicking. I don't know, like you have to be human, right? So you kind of have to be gentle to the person getting the feedback. All right. So what's the ideal merge request size? Yeah, that one does not have a correct answer. It is sort of I feel this one and this one are both correct answers, but it's sort of it depends, right? There is no single answer for this question. Sometimes you're doing refactoring and you had to touch all the files in the repo, right? And then the merge request is massive because you've done refactoring. I mean, you can try to say, okay, can I split the refactoring into smaller stages and sort of do one stage at the time and make it smaller? Then you should do it. But sometimes there is no way. The easiest way is just to fix everything in one go. So sometimes you have to be here. but normally you should try to be small. So if you're working on a feature, you just work on that one feature, you finish it, and you make a merge request. You don't start working on another feature, right? So you work on one thing, finish it, and merge it. So make that the work kind of contained and small. So I'm working, as I told you, with the student, and he often, like after a week, comes to me and says, yeah, can we review some merge requests? And I'm kind of sitting with him and reviewing it. And sometimes it's like 8 merge requests, right? And some of them are very tiny, like just updating a version number of a dependency and like 1 or 2 line changes. Some of them are bigger. Some of them are, quite large because we have to update something like massively. So there is no kind of single answer, but we try to go as small as possible. Okay, another quiz question. So you're reviewing code and you spotted kind of a variable name, which is like weird. So nit means nitpicking. And what do? So you're reading the code, you are the reviewer, and you feel, oh shit, like somebody named a variable foo. Okay, what is foo? Then what you do? Yes, you should do this. You should flag it. You should say, well, maybe we should use a more meaningful name for that variable, but everything works fine. There is no problem. There is no, it is a small issue, right? You should accept. You should like flag it, but you should accept the merge request. It should go in. And there is another comment like nitpicking, right? Nit. All right, pipeline. Yeah, a little bit of pain to set up, but once you have it, you love it. You don't ever think about it. You just like the green tick boxes every time you push something to the GitLab, and then it says, yes, all your stuff passed correctly, right? So after the push, you enforce the coding style by the make vet. Then you enforce the correctness by testing. And if there is no code style problems, if there is no test, then you build. If there are code style problems, you fail. Like you don't do anything more. Why? Because you want to fail fast and don't waste resources, right? So if there are some style problem with the source code, you don't spend time building the library anymore. There is no point building it if there are things to fix. So you start with style, then tests, and then build. Yeah, one job, stages run sequentially. If you have multiple tasks to done in the stage, you can run them in parallel. But normally it's super simple. You just say make vet, make test, make build, sorted. Should your tests set up a database? Normally not, right? So normally your unit test should have mocks, and you should not be setting up any database or should not be setting up any servers or anything. For end-to-end tests, especially in the cloud, you may want to set up some Docker stuff and kind of test with your database and so on, right? So then you have to set it up in the pipeline. Like you can spin Docker container in the pipeline and kind of set up your environment the same way as you're setting it up like locally, and then run some end-to-end tests. But they will take more time and it's more resource intensive and it's more time consuming. So for faster things, for unit tests, always use mocks. All right. This is like a very simple schema for GitLab CI YAML file. So you're saying, okay, use this Docker image. Let's use Golang 126. We will have 3 stages. We will do vet, test, and build. And then you set up some variables. And then you say, okay, for vet, we running make vet. For test, we're running make test, and so on and so forth. And then you're setting the path for some artifacts. What are artifacts? Artifacts are the generated kind of stuff that the stages can generate. So for example, the test generates some failures of like test failures, or linter generates some linter failures. Those are artifacts. And then where would you like to store them? And then like for binary, you can store them in bin, and then for some other ones, you can configure it. So the ordering vet test build, vet first to catch all the easy things to catch. It's the cheapest. Test second. This takes longer. And then if you need to build your library, build the executable, that's the longest one. So you run it last. Failing fast saves the pipeline resources and your time. Right. So when using the pipeline, and also when you're using the your own build process, it is kind of nice to use Go cache and Go mod cache. So again, I will show you. I will show you here. So let's go back to my project. CD projects. Yeah, we can go here. So if I show you my Makefile, I am setting up some folders. So Go cache. I say, okay, use the current folder we are in and use this subfolder for Go cache and Go mod cache. And what it does is if I like build it and do everything, you can see I kind of use those inside the current folder, right? So let's let it run. And then if I, okay, I show you. If I kind of look, I have the folder Go cache, and I have also this folder locally, which I ignore in git ignore, but they store all the kind of things that are downloaded, and it sort of saves the resources, right? So it saves my resources when I run it because I'm caching everything, and it also saves the resources when you're running it in the pipeline. So it's kind of a nice to do it with the caching. But it is not like you don't have to have it, right? It will just run slower and it will waste a little bit more resources if you don't follow the caching kind of mechanics. But if you have some spare cycles and you kind of want to make it even more robust, then you should use the Go cache and Go mod cache in your Makefile, such that when you're running it in the pipeline also caching things and kind of reusing things, right? For different activities. And the cache is kind of makes the building and testing and linting kind of faster. There is another one for linter as well. So it's nice to have. You don't have to have it. What just happened? All right. So another quiz. So if you see those four, which one do you think is catching linter violations? As I said, sometimes people have a dedicated one. Sometimes people have linter, like target, just for linter violations. But in some cases, vetting is where you vet and lint together. So that would be natural choice compared with the other four targets. All right. Yeah, we're doing fine. 4 more questions. We didn't talk about it, so you have to guess. Yes. You don't want to fiddle with your mod file, and you don't want to fiddle with your dependencies. So the mod read only means don't touch it, like use what's there and don't change anything. So it prevents accidental modifications when CI runs on top of your code base. All right, any questions about the pipeline? The GitLab YAML file, the GitLab CI YAML file, if you are creating it for the first time, is a little bit of like black magic. Like you have to get to know the syntax and what to use. But I gave you in the example, I gave you like a template and it should work. So it's a starting point. And then once you have a starting point, you can kind of modify it, right, for your needs. Okay, so let's let's talk a little bit about idiomatic Go. So I kind of love it because it's exactly why I also dislike Golang, right? Because Golang has this philosophy of like, you know, clarity and simplicity is better than being clever. And it makes it really impossible for you to be clever with Golang code. Like it's such a dumb, like simple language that you have to be clear and sort of verbose, right? In Haskell, you can be clever. In C++, you can be clever. In Rust, you can also be clever. But in Golang, you cannot really be like super clever, right? So it's one of those debatable things, like, is it good or is it bad? Is it good to give developers expressiveness and ability to be clever? Or is it not good? And Golang says, no, it's not good because the developers will abuse it. They will create this very complicated, clever things, and other developers will come and will not understand it, right? That's the argument. Yes, I can agree that you can write C++ code that nobody understands, but it's super clever. But then again, it gives you power. It gives you ability to solve complexity. Same with Haskell. Like we can deal with more complexity because we have more tools. We can actually be clever in organizing the complexity, right? With Golang, you cannot, which means you will kind of at some point, you will reach a level where it's too complex, like it becomes unmanageable because you have too much complexity and you cannot cleverly organize it in a different way, right? Because there is only this sort of a verbose way of dealing with stuff. So having said that, it's kind of a balancing act of how much expressiveness you want to offer and how much abuse can happen, right? So for example, C++ templates are very expressive and very powerful. It's a very powerful mechanism for doing meta programming in C++, but the amount of abuse, it's so big that almost nobody uses it because it's like so hard to use it in a way that is actually usable for everybody, right? It's so much power that it kind of very quickly turns into the dark side, right? With Haskell, it's a little bit similar, but it kind of depends. It depends how much, how in the language you are already in, right? If you're already in the language for a long time, then it like you kind of deal with this cleverness more naturally, right? It's a little bit kind of conflicting. But anyway, idiomatic Go. So let's look at some patterns. So you should not panic. It's a simple one, simple rule. Like if you're panicking in your code, then you're kind of doing something wrong. Like you should handle errors yourself, and you should only panic if there is something truly unrecoverable, right? So generally, you should never panic in your code. Like if you're calling panic, you're probably doing something wrong 99% of the time. So, and errors are values. So you should use what we talked about, error 113, that you should have constants and you sort of returning some errors from like this call will generate an error, and then you're wrapping that error with something with some extra information, but you're reusing that value here, right? So if there is an error, never panic, like handle it or propagate it to the caller. Eventually, something goes to the main, and then if main cannot handle it, then the main will quit, right, with some error message. But you should not panic. This is only for something that is like completely unrecoverable and completely unexpected, right? that you should throw a towel. It can happen. There are situations where you're building a library and you sort of are getting to a situation which should never happen. But normally you should avoid panics. Simple rule. So then interfaces. Golang also forces people to make interfaces very simple and usually just one function inside the interface. That would be preferable, right? Which is weird. Like if you're coming from C# or if you're coming from Java, where you have those giant interfaces for a lot of methods for your abstract classes, right? Here, you should not have interfaces like start, stop, reset, render, get state, blah, 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 like game engine interface. That's very non-Go-like, non-idiomatic Go. You should have the renderer interface, stats interface, or state interface. That should be E, like stat is a different word. And so on. And then you can combine it together. You can combine an interface which is composed of other interfaces, but you should not have interface like this. So try to keep your interface to one, maybe two methods. That's it, right? If you need 4 methods, think like, why do I need 4 methods? Maybe I can split it. Maybe those are 2 things that are going on, right? So one responsibility at a time. Okay, typical thing that we do wrong is we have to propagate something. Like we have something that needs to be propagated through the methods or functions. And then we say, yeah, let's stuff it into the context. Like let's stuff it into the struct. And context is one of the examples, right? Sometimes it's a database handle. Sometimes it's the error handler, which kind of leads to standard output or to a file, something like you need to kind of initiate something and then use it, right? And the temptation is, especially if you're coming from object-oriented programming, to sort of stuff it into the struct. Like here, we have a service, and then we say, okay, let's stuff context into the service, and then we will use this one from the struct, right? You should avoid it. What you should do instead, you should pass context as the first argument to all the methods of your struct, and the struct should have nothing, right? Why is that? It is because it's easier to test things in isolation, because you don't have a global context which everybody is reusing. You're sort of propagating some mocked context to particular isolated part of your processing, and then it's sort of easier to plug and play, right? So it's easier to dynamically compose what functionality you need. Otherwise, they baking it up front and then making it harder to be tested, right? So for testability and for robustness, it's better not to stuff things into struct, but rather keep it passed around. But then you say, yeah, but then why we have struct, Mariusz? Like, what should we store in the struct? Well, in the struct, you store what actually is the struct about. So if the struct is about like the student data set, you have all the properties of a student there. If the struct is about processing URL requests in your kind of a REST service, maybe you can kind of keep some persistent things in there, but the context is sort of propagated individually. So you kind of have to arrange your architecture in such a way that you don't overcommit into storing something that actually you want to be dynamic and you want to mock. So normally what you say is, you can ask yourself, do I want to mock it when I'm calling it, or it's not possible for me to mock it? If it's not possible, then you have 2 choices. It's either should be baked into the struct, or you're doing something wrong, and you should kind of make it mockable, right? Okay, so then similar thing, dependency injection. You should not have kind of things which are baked by, like, so here we sort of saying we will have a standard out, and then we bake this variable from outside of this function, like that they should be like new line, right? So the line finishes here. So we have this variable, and then we baking this variable into the print function that it always prints into standard out. But that means it's hard-coded. Like we cannot mock it anymore. We cannot test it. So a better way is you say, okay, I have a runner struct, and I'm kind of specifying what the in and out are, or out and error are. And then I have a function which kind of accepts it. And then we have the kind of the baking done dynamically. So I can kind of dependency inject. A typical scenario is you, for example, have a database handler like a REST, like the request comes in and you have a handler and you have to bake in the database access to that handler, right? And if you bake that in, if you actually set it up such that that handler is using your real database, then you cannot test it. You cannot call that handler with a fake database, right? So you have to make it such that when you have the REST handler and you have to inject the database to it, it has to be done in a dynamic way. So you have to pass something that can be mocked, and that mock gives the handler a different database, right? Instead of directly giving a database connection. Maybe I should change this one to the database because it's a little bit easier. So table-driven tests. There is a tendency to say, okay, I have something to test. So what I will do is I will kind of say, let's say we have a method foo to test, and we have like two integers, and we say foo those two integers. Did it work? Okay, and not, yes, blah, blah, blah. Okay, another test. Foo with those two numbers. Did it work? Yes, no, blah, blah, blah. Foo and other numbers, and so on. And at some point, we kind of copying and pasting the same code over and over because we're doing the same test on different values, right? So you should isolate the logic of the test from the values. And you should always use like a list or table, like some form of data entry, and the logic of the test in a loop, and take the values, the expected value, and then values and expected value, values and expected value, and run it in the loop. And this is called table-driven testing. So instead of doing one test at a time, you're testing a class of tests in a loop with the values given. Does it make sense? It's a little bit abstract. Like I don't have the example, but you know, you typically, like, you have to test something, like you have to test something, but when you're testing it, you can pass it different values, and you're doing one at a time. You should not do that. So if you instead, like, you should start with it. Like you should say, okay, I have to test it, and I'm testing it with one value at a time. But then you should kind of expand it into a loop and say, I'm doing exactly the same test. I'm checking if for these values I get a correct result, but I'm doing it in the loop, and I'm passing multiple cases, like different edge cases, different values, and I'm doing it in one go. It's one test, right? First of all, you're reducing the copy and pasting of your tests, so it's more compact. And second of all, it's much easier to find a bug if the values and the expected value are wrong, because you actually have organized it in a form of a table. Like you have, for those inputs, I expect this output. For those inputs, I expect this output, and so on, right? I will maybe create a table example for this, because this one is an important one. All right. I will probably need another break. Right. So we learned we should never panic. That's a bad thing. And it's not only Golang, like we should never panic in any programming language. We should always gracefully handle errors and propagate them to main. So we should not panic. We should not panic by logging the panic, because this one will also stop the program, right? It means log this and like panic. So those two are there. They can be cases where you have to use them, but you need to know why I'm using one of them. Normally, we don't use them, okay? And then we learned that the linter R113 will pick this and say, you're doing something wrong, don't do it. Like no new errors, use sentinel errors. So that means it's only this one left, right? So the other three distractors are actually like really not to be used. This one will be picked by the linter, and the other two you have to have a really good reason to use. So we are wrapping the error, the value error, in some sort of context by doing this injection. So it's a nice way in Golang to handle kind of more and more complex errors, right? And this one will propagate this error up the chain, and you can wrap it again in another context, right? You can have multiple levels of wrapping the errors. Okay, so then let's do one more question and we'll have a break. So Go context, this is really for cloud. Like you have to deal with context, and you should not stuff the context into the structs. You should kind of propagate it through the different methods. Yes. So you should do this. Again, it's like the default. There might be special circumstances where you want to have it in the struct, but you have to have a good reason for it, right? All right, so let's have a break. 10 minutes? Let's do 10 minutes. I already pushed the code into the repository for task 11, so you can pull it. And the game, it's a tic-tac-toe game, and the bad game is already implemented, and you can play it. There is a random AI which plays with you, and it makes, if it can play in the middle, it plays in the middle, and if it cannot, it plays random move. But it does not have a logic to play a move to win. So if it has two in a row, it makes a random move instead of the move to win, right? So one simple extension to the AI moves is, okay, do the move in the middle. If you cannot, check if there is a winning move. If there is a winning move, make the winning move. If there is no winning move, make a random move, right? And then it would make the experience much nicer, because right now it's super dumb. Like it just makes random moves. So you will always win with it. But if it kind of makes the move to win, then yes, it will kind of be a little bit stronger. Right, so let me break. All right, let's continue. We don't have much more to go, just a couple of slides. So we talked about context, and now we talked about some idiomatic patterns. As you can see, there was not a lot. Golang is quite a simple thing, and also, as I told you, like the Go critic, Go vet, and the linter will pick up a lot of mistakes or a lot of not idiomatic things that you do, such that it will force you to do sort of idiomatic things. There are some more complex patterns, especially with the functional flavor of passing functions to functions. But I didn't want to kind of collude too much, and you're probably not using a very complicated machinery yet for assignment 1 in cloud. So we will come back to that a little bit later. Like at the end of like Haskell, we will kind of talk about those more functional patterns that are idiomatic in Golang as well. So common mistakes in Golang, there are a couple of them. Don't panic. Yeah, we talked about this one. Ignoring errors. Yes. So like, sorry. Ignoring errors, it's something that the Go linter will pick up and it will force you to handle errors. So you cannot call something that returns an error and kind of ignore it. Like you have to get the error and do something with the error. So usually you have to say, if there is an error, I am doing something with the error, right? So this is a pattern that Go like enforces, and avoiding it is a anti-pattern. Like you should not avoid doing it. You have to do it. It is a bit painful. Like it feels a bit tedious that you have to do it, but you have to do it. So don't ignore errors. The second one is spaghetti code, that you have everything in one package called main. Everything is inside main, right? Easy, don't do it. So those are no brainers. This one is complicated, and this one is a little bit difficult. So Golang, same as with other programming languages, has a concept of untyped kind of a something, right? So like null in C++, or nil in Python, or some empty, undefined in JavaScript. There, all languages, they have something that means we don't have a value and we don't know what originally the value type should be, okay? So it's a no value of unknown type. And interface curly braces means the same thing. It means there is an interface, we just don't know like what it is, and this one fits all possible interfaces. It's like a generic one. It says kind of anything fits this one, right? You can pass anything, right? So it gives you flexibility, it gives you power, but at the same time, it gives you no information about what it is that is there or should be there, right? So there are places where you have to use it. Of course, you have to use it. Same as in Java, you have to use like object, that you're passing an object to something. But what does it mean? Like, what is the object? Like, it can be anything, right? You have no idea. But sometimes you want this general ability to do meta programming. You just programming on something very generic. And this is this mechanism. But it loses type safety, right? So the compiler will not help you, and that other developers will not know your intent, and you're kind of losing type safety. So it's a very powerful mechanism for doing meta programming and being generic, but at the same time, you're losing what it actually is, right? So in many languages, like in Haskell, we say, okay, let's have our own type of maybe something, and then there's our own type of maybe something kind of can give you nothing or can give you something, and the generic something is constrained by some meta classes or traits in Rust, right? So this is a mechanism that you want to use often, but you should not abuse it. So if you find yourself using interface curly braces like in a lot of places, you have to like, okay, wait a minute, like maybe we should introduce our own types, like our own type system, and aggregate certain functionality in the typed interfaces, because you want to make the type system play with you, like to help you, right? You don't want to force yourself on the type system saying, I don't care about you, type system, I'm gonna use this. And then the compiler will always compile, right? You want to say, no, okay, I like type system is for you. It is like, again, I'm kind of doing it very abstractly. I don't show you the actual examples, but you will notice that, like, pay attention every time you have to use interface curly braces, and if it is justified. If it is justified, fine. But if it is not, maybe you need to use proper typed interfaces instead, right? Magic numbers and magic strings, okay. Linter solves that problem. MND and goconst solves that for you. The linter will enforce the quality for you. All right, so we zoomed through it a little bit. We have 2 remaining quiz questions, so let's do that. What is the anti-pattern in that call? This one? Should you, if you are the code reviewer, should you stop the merge request if you see something like this? Who thinks you should stop merge request? Yeah, I think we should stop the merge request. It's serious enough. You should handle errors. Will the code work? Yes, in the happy path, the code will work. But in the unhappy path, we don't know like what's gonna happen. Like something will happen, but we have no control of what will happen, right? If we hit the unhappy path. We have to deal with unhappy path with same diligence as we dealing with the happy path. Has to be solved. Error has to be handled. We have to stop the merge request. We have to complain. All right, the last one. Yes, we're losing type, compile time type safety. The compiler is not our friend anymore. The compiler says, I don't know, like you didn't help me, I cannot help you. So it's a compiler thing. GoVed will probably not complain if you do that. Should we not have assertions in the production code? So what do you think? Who thinks like when we're developing and we have a development branch and we kind of doing the coding in C++, you can assert certain things. And here in Golang, you also can assert if the certain type, if a certain variable is of certain type. So you have certain assertions. And the assertion, basically what we'll do, if it succeeds, it's a happy path and it will work. But if it fails, it will panic. It will say, yeah, like I'm throwing a towel, like the assertion didn't work, right? It's a type that I did not expect. So what do you think? Should we allow assertions in the production code or not? Who thinks they should be allowed in the production code? Who thinks they should not be allowed in the production code? You have to have an opinion, come on. So the answer is obviously nuanced. Like there is no one single answer, but the answer leans towards not having assertions in the production code. So if you're running the code and it panics and throws you a stack trace, for a developer, that's an information. Like I know now what's going on, what we need to fix, right? But if it happens in the production code and you get the blue screen of death in Windows, like what is your user experience with blue screen of death in Windows, which is basically a failed assertion? Well, it's terrible experience, right? So why would you want to give user that experience? You don't, right? So I think typically 99% of the time, you don't want assertions in the production code. You want to handle errors in a different way, right? And if you can recover, you should recover. If you cannot, you have to tell the user something else than the blue screen of death, right? You can gracefully shut down or something, maybe, right? I mean, you have to do something else. Like the blue screen of death is the prototypical kind of a worst user experience kind of situation, right? So lean towards not allowing assertions in the production code, which means if you have to do assertions in your code, it is fine for development, but for production, you have to think, why I'm doing this assertion here? Should it stay for production? If not, then I have to change it, like make it into a typed interfaces instead of interface curly braces, and make the compiler catch things that don't match anymore, right? Because the assertion means you're passing something of a type that is not supposed to be there. And if everything is typed, the compiler will catch it in the compile time. It will tell you, no, you cannot do this. This is of the wrong type, like you cannot fit it here, right? But if you're using the generic type, the compiler may not pick it, right? Haskell is very good. Actually, Haskell is very good in working out with generic types of what can and cannot happen and how things should and should not work. And 99% of the time, you are fine with Haskell doing the good things, but you don't, in Haskell, you typically don't make assertions, actually. It's type, like it's the type system work to do it for you. So in C, C++, Golang, and so on, try to avoid assertions. So you're losing type safety effectively. Great. So we went through all of this. It's quite a packed lecture. We have some people doing reasonably well. Yeah, just very small, small differences. So Yaya, congratulations. Who is Yaya? Yeah, great. Good job. Now we will do this practical thing. So as I said, I committed 2 games of tic-tac-toe. One is just the implementation of the game where you can play with the computer in the terminal, and it does most of the things wrong. It's sort of, it works, but it's a bad example. And then there is another folder, which is a skeleton. It doesn't work yet. It's more complicated because it splits everything into files. It has a lot of comments. It has a lot of tests, and it forces you to do the right thing. So it kind of complicates the development process, but it is sort of following what we have taught today, and it tries to avoid all the pitfalls. And it also has the Makefile, and it also has the pipeline already pre-prepared. I have to admit, I haven't tested that the pipeline works. I tested that the Makefile is okay, but you have to implement it to be able to test, because right now, like the tests fail because the implementation is missing. And also the good implementation is using panic everywhere to say, we haven't implemented it yet, so we have to panic, right? Panicking for something that you have not implemented yet is fine. It's the development process, right? It's the same as saying that something is undefined in Haskell. So if you want the compiler to compile your Haskell program, you can specify everything and say, for the implementation of your methods, you can say equals undefined, and it's okay. The compiler will compile, but the program will panic every time you hit something that is not implemented yet. Same here. But for the production, of course, you want to remove it. So the task for today is convert the bad implementation into good implementation by copy and paste, set up a new project, and then organize yourself into a nice workflow such that you do semantic commits and you try 2 or 3 merge requests, okay? Don't go overboard. Organize yourself maybe into 3 issues, like dealing with player, dealing with game, and dealing with testing, and then make 3 issues, make 3 commits for the 3 things, and make 3 merge requests. Maybe you want more commits. And then that's it. Like, don't go like too overboard with this. It's just to get familiar with the process. And that's it. And the deadline is not today. The deadline is in the future, so that you have enough time to play with it afterwards and to prioritize the assignment 1 for cloud this week. And that's it. Do you have questions? So what we do today till the rest of the class is play with Golang and play with those things. Maybe copy some of the make files to your other projects to test like how many linter problems I have in my code and so on, and just get familiar with it. Once you start using the linter, yeah, there is no going back. Like you will love it. So, okay, that's it from me. Thank you and good luck with the task 11.